Enjoy the yummy chicken spread range. Young's Chicken Spread. Full of nutrition, full of taste.
Hey, you! Oh, crap. Yeah, you. Let's talk about mentality. With any mind sport beyond just competitive programming, such as chess and even school and learning stuff, yeah, I would count those as mind sports too, it's so easy to associate skill in that sport with your actual intelligence. And it makes sense to do that, right? Well, no. Not really. Because any failure in said sport is going to feel totally personal, and it's just going to suck. But your skill in a sport is just that. Your skill in that sport. And it reflects little on anything else about you. Like seriously, you're worth so much more than your skill in some sport or game. It's really just a trap to do this, to associate your intelligence or ego or worth as a person with any kind of mental sport like this. And this video is going to be about some very dangerous mentalities that spawn from mental traps like those, serving as both a warning and advice for how to get out of them. So let me describe these mentalities. First, any kind of self-deprecation is harmful. If you tell yourself something enough times, you're going to start to believe it, regardless of how you actually feel about it. And when you think you're stupid or inadequate for not having success or being good at something, you're pinning the blame on your self-worth and intelligence, but this doesn't make sense, because your performance in anything is only a measure of how good you are at that particular thing. So it doesn't make sense to attack your self-worth because of some performance, since the only thing that performance measures are your skills or knowledge, which you do have the ability to change. So put the blame on those, and then fix them. A tangentially related issue is comparing yourself to other people. Of course, these comparisons are bad for you, and your experience is going to be different from those around you, and often times others can and will do better. But it doesn't matter. You're really only up against yourself. And thinking about the progress of others is only going to be a distraction, because it's not going to help you with your own progress. And something else that's not going to help you is thinking that there's some uncontrollable, like, external factor stopping you from being able to achieve what you want. For example, I hear people say that their brain isn't wired to do, say, math, or that everything they do depends on luck, or there's some system that's biased against them. And these can be true, sometimes, but there's no way they're always true. And that means you should focus on when it isn't true and focus on what you can control. In psychology, this is called an external locus of control, where you essentially blame the external things for having control over your life instead of yourself and what you're doing about it. And of course, it's bad. A very common instance I see of that is people saying they're always going to be bad at something because they're, like, new to it. And I mean, it's like a reasonable thought process initially, but not when you have it all the time. So, like, sure, you're new. Okay, then learn stuff and stop being new. Otherwise, you're never going to stop being new. Like, if you don't know something, the reason is that you don't know it. Leave it at that so you don't trap yourself in a mental ditch that you can't get out of. The final issue is the idea of doing something purely to get good at it, to get good results, and being happy only when you do get good results. And it's fine to have goals for something, but if you only enjoy something when you're constantly getting better, you're going to be very disappointed when you don't. And you can't always be going up. So there's going to be some disappointment. To remedy that, you've got to find some enjoyment in the process of improving and practicing and getting better. The results are going to disappoint you from time to time, but the process never ends. And if you enjoy that, you'll always be able to find some enjoyment in the activity. Now, those are the main things to look out for, and they're all just really toxic thoughts to have, especially the heavy self-deprecation. Now, I wanted to share my story of experiencing this with competitive programming as well, since it's a huge part of what inspired me to make this video. And some of these may seem like absurd thoughts, but I don't really care. This can happen to anyone, and it's never absurd to realize it and take care of yourself. So let's start with the time I was in the 1800 region in Upper Expert on Code Forces. It was only about a month and a half, but every contest stung worse and worse. Each time I made some new kind of stupid mistake, and for whatever reason I took each one super personally. Like, I felt like I had to be perfect, and with each mistake I was just letting myself down. And there was nothing
Hi! Your unconscious mind is absolutely crap. Seriously, it controls so many of your most powerful brain processes. Intuition, insight, most of creativity, and basically the vast majority of the thinking you do all goes on in the background. Some have claimed your unconscious mind is hundreds or thousands of times more powerful than your conscious mind. And I would say one of the biggest advantages that successful people have is that they know how to focus this incredible source of brain power on whatever they're trying to accomplish. There's a famous post by a former world #1 competitive programmer that claims the same thing. The best people are all able to think about things passively, even during random tasks like showering or skydiving, and keep their unconscious mind focused on the task they're trying to figure out. So you may be asking now, how do you do this too? How do you control the raw power of your unconscious mind and get it to listen to you? And I'm going to offer you a habit. Something easy, in fact. Something you only have to do for a few minutes a day to keep your unconscious mind focused on what you want. But despite its simplicity, it'll work very well because it draws upon what drives your unconscious mind in the first place. And that sounds really nice. And it is really nice. So enjoy the video. But first, let me tell you who I am. All my points are going to be logical, but it'd be good if you can trust my experience too. So I'm one of the world's best competitive programmers. That means problem solving. And I had an extremely quick rise to the top. And probably the biggest reason for this is that my unconscious mind was extremely invested in my success. Because even when I wasn't consciously thinking about problems, my unconscious mind was churning out ideas in the background and constantly rewiring itself to get better and better at problem solving because it cared so much about improvement. And the hardest problem I ever solved in a contest was solved through insight. which is when your unconscious mind out of nowhere gives you a really good idea. In fact, I personally kind of lost interest in the problem. I thought it was too hard for me. But my unconscious mind stayed focused and cooked up ideas in the background. Eventually gave me a really good idea that ended up being correct. So my unconscious mind is very much on my side. And after this video, you're going to learn how to set that up yourself too. But before we start that, let me give a bit of info on what the unconscious mind is and does for us. And I'm not going to make this sciencey, so don't worry about technical stuff. Just some basic facts. So what's important for this video is that your unconscious mind is a background process, something you don't have conscious control over. So by default, it's doing random things like regulating your body temperature and making sure you're still breathing. That you're breathing manually now that I mentioned it. You're welcome. And it's unbelievably powerful. Just think about how much your body does automatically. Things you don't even realize are happening. Even a fraction of that raw power can be incredibly helpful to you. Like, let's do a speed test. Add 2 and 3. That was instant, right? Probably before I even finished the sentence. That's because the task was so simple, your unconscious mind just decided to handle it for you. Now add these two numbers. Probably not so instant, right? You can break it down into a bunch of easy parts that your unconscious mind can handle, but it probably can't do the whole thing. And that's because you probably don't have the addition algorithm ingrained in your head. So what you had to do was consciously perform the steps of addition with carrying and such, and feed those smaller tasks to your unconscious mind to handle. But that was orders of magnitude slower because your conscious mind is weak. So you want your unconscious mind to do as much for you as possible. And it's capable of a lot of complex thinking, such as offering insights and intuition, but only when it's interested enough. And there's a comment on my intuition video that summed up all my points better than I could. Basically, your unconscious mind is this ultra powerful computer, and your consciousness is like the keyboard telling that computer what to do. And that's pretty much what's happening here. Your goal is to give your unconscious mind the task of helping you with whatever you're trying to do. You may have to simplify your task, you may have to break it into smaller pieces, but ultimately you want your unconscious mind to focus its power on your task. And the tricky bit is it's usually not enough to just try the task. For some people it is, and we'll cover why very soon. But for most people, you have to do some extra work to get your unconscious mind really invested in it. And finally, now we'll talk about how you do that. So now the question becomes, how do you control your unconscious mind and give it a task for it to focus all its power on? And the key is to get your unconscious mind to care about something. And this will sound very dumb, but to get your unconscious mind to care about something, the only thing you have to do is to care about that something. But I don't just mean caring. I mean caring.
By drawing daily sketches, you can develop discipline, improve your skills, and foster new ideas. It serves to relieve stress.
Caring. Like, loving something so much that just doing it brings you significant happiness by default. Or on the other end of the spectrum, caring so much that if you fail at something, you feel like your very survival is threatened. You feel genuinely afraid of failure. And these are things that your unconscious mind can recognize. Happiness, fear, survival. Very basic, primal, fundamental human nature emotions that result from your caring. Your unconscious mind wants to be happy. If you get good at your task or even just do your task, you'll be happy. Therefore, your unconscious mind will focus on the task. Doing what you love is one easy way to accomplish that. If you fail the task, your survival will be threatened. Your unconscious mind doesn't want that, so will focus on not failing the task. And nothing artificial will work. There's no inherent primal value in money or prestige or success or any of the things that motivate most people. Your unconscious mind just doesn't care, and therefore it won't try to help you. So if that's what you're working for, you're gonna have to turn these artificial motivators into primal emotions that your unconscious mind will care about. So let's get into exactly how you do that. And let's start with an idea of the chain of motivation. So let's imagine a conversation with someone who's studying computer science. They'll say, I want to study computer science. I'll ask why. They'll say something else. If their answer is that they love it, then they've already won over their unconscious mind. But they probably won't say that. So let's imagine what else they can say. For example, they can want a good job, and I'll ask why. And they can say, so they can earn a lot of money, and I'll ask why. And this can again branch into a bunch of different reasons. Let's imagine a common scenario. They say they want to support their family. So I can again ask why. And maybe this is the point where it becomes about happiness or love or emotional connections or whatever. Eventually, it will reduce to some set of primal emotions or nothing at all. And if it reduces to nothing, then you should seriously consider why are you doing this at all. What's the point? If there's no benefit, are you really just wasting your time? If you don't get anything out of your thing, this method won't help you. But at the same time, if you don't get anything out of it, the thing might not be helping you at all. So really consider that. But if it does lead to some primal emotions, then your goal should be to focus on those. And let's call these primal emotions your key motivators. Things that your unconscious mind recognizes and will focus on. In the ideal scenario, you love what you're doing, and therefore your key motivators are right next to you. That means your unconscious mind is by default focused on those key motivators and therefore also on the thing you're trying to do. So you win. But if you're watching this, that's probably not the case. Your case probably looks like more like the hypothetical CS student. So you want to turn your case into the ideal case. And how do you do that? Well, as an example, try to visualize yourself achieving your goals. For example, having a lot of money, being able to buy nice things, etc. It's nice, right? Probably brings you good feelings. Just think about how happy you'd be if things worked out for you. Let that happiness bleed into the present. So what you ultimately want to do is associate your task directly with those good feelings. Skip the long chain of becauses. This is what I want. This task is how I get there. Nothing in between. Burn that association into your head. You've probably heard of Pavlovian conditioning. By using a metronome to signal the arrival of food, Pavlov got dogs to salivate just by hearing the metronome, since ultimately they form the association between the metronome and the food. That's ultimately your goal here. You want progress on this task, for example, a success, to directly associate with happiness. And your unconscious mind will recognize this association since it has to do with the key motivator. And on the other end, you can also try to get failure to associate with negative emotions. And this is a risky game because you can make yourself unhappy, but it will probably let you be even more focused since your unconscious mind will work on avoiding those negative emotions. So I promise you a habit, something you can do for only a few minutes a day. What can you do to make this conditioning happen? And the first thing you have to do is figure yourself out. So on day one, take some time out to figure out how your motivation works. Have the why conversation with yourself. Inspect your motivation chain. Like literally draw out this diagram if you need to. Understand what drives you. Figure out what your key motivators are. And on the rest of the days, you can work on this conditioning. You want to get rid of the stuff in the middle. So embrace Pavlov. Start doing your task. And while you're doing your task, think about whatever your key motivator is. Imagine success. Imagine yourself getting what you want. Imagine happiness. Or imagine failure and dread if you don't succeed in the task. Make yourself feel these positive or negative emotions while you're doing the task so that those emotions get associated with the task. Again, nothing in between. Ignore the rest of the motivations in the chain. Just your task and the key motivator. Condition yourself to recognize that your task will directly lead to your key motivator. In a similar vein, you can reward or punish yourself for success and failure. Doing that will give yourself a direct, short-term way of feeling those emotions as a result of your task. And also visualize that reward or punishment while doing the task so you can associate those emotions with progress. And that's the habit. Spend a few minutes a day conditioning yourself. You don't need to do it for a long time. There are diminishing returns anyway. But you can do it multiple times a day or as often as you feel like. And the more time you put in, the faster your unconscious mind will recognize your goal. But you don't have to do it that often for it to work. Just do it consistently. And that's all you really need to do. Convince your unconscious mind to care by associating your task with primal emotions that it cares about. Mental change is achieved through repetition. So do this daily and you'll see results fairly quickly, just as Pavlov did. Some other things to note. Ego can be a very good key motivator. So let's do an example. What's my motivation chain? How does this work for me? So why do I do competitive programming? There are a lot of reasons. For one, I love problem solving and I also love coding. So there's two good things. But there's another reason that trumps both of those, and that's ego. I do this problem solving stuff ultimately because I want to prove I'm smart. So any success is a decent ego boost, and any failure makes me feel basically worthless. So obviously my unconscious mind has an incentive to contribute here. And I've sort of done this conditioning automatically, but I take any failure very personally. It hurts to fail. Like physically hurts. I would say I'm that guy that equates failure with threatening my survival. So my unconscious mind is very invested in my success. And it's not exactly the healthiest setup, but it works very well. And you should take failure personally too. For example, suppose you can't learn something or you can't get good at something or whatever. How can you let this minuscule task make a
morning, guys. Now, we'll try one more contest. Bismillah. Alhamdulillah. Let's explore it. Or should I hold on a charge? Notation warm-up. So we have notation of length n. We define the function f of p is equal to p of I minus I. So you are given a number n, you need to compute how many distinct values of function f. So we define the function. We are given a number n, you need to compute how many distinct values the function f of p can take when considering all possible permutations of the number from 1 to n. So first thank you has increased in the number of numbers in the permutation. So 2. Now for the case of 2, function takes 2 distinct values. Total of 3 values. Now n is 500, so We can do n squared as well. Mm. How many distinct values function fp can take? So we have numbers from 1 to n, 3 values. So we have numbers 1, 2, 3. Then we can subtract them from 1, 2, or 3, right? So how many possible values do we get? So in this case, we are going to get a 0. And similarly, if we move everything backwards, right? So if we move this to here, this to here. So what happens in that case? This becomes this becomes 1 actually. It also becomes 1. And when we do this, it also becomes 1. So if we have 1, 2, 3, 1, 2, 3, and we subtract this, we get 0. If we subtract we get 1, we get a 0, we get a 1, and we get 1, 2. And if we do this, so let's see, we have a possibility that we have 1, 2, and 3, right? And when we are subtracting from this, it's going to be the 0. And the second case is where the value of I becomes greater than value of a pi, right? In that case, pi becomes greater than I. In that case, it's very straightforward, right? So let's say this becomes greater than pi, so this one comes here, this gets treated, so it's going to be 2, and that's not a problem. It's no problem. And if pi gets more than I, then it also remains positive. And so what does that mean? That means that if a number is negative, if a number gets positive, it also has a negative counterpart somewhere. How do we understand this problem? So there's supposed to be some sort of
इसकी कितनी बैटरी है देखो सर
so we have one,
दूसरे
two, three.
इना को पता नहीं क्या है
Let's say that
पता क्या है इनके नजदीक ना पता क्या है
so it's a very weird problem. So it'll be 0 and 2. So I have three values 0, 2, 2, 4, 4, 4. And my prediction is that it becomes 666. Right? 0, 2, 4. I don't know why I'm struggling with 800 so far. These problems used to have some sort of caveat, if I'm not wrong. And finding that caveat is getting harder for me. So now 1, 2, 3, right? We do this, it gets a very straightforward answer. But let's say that we swap around these values, and if we Okay, so how many possible values are there now? I think we can use something like we can. What's the biggest possible difference we can make? You can also have 1, 2, 3, and then we can also make I think it's about the swaps. 2, 3. Three, two, one. So 1, 1, 0, 0, 0. This 0, 1, 0, 1. So what happened here? We swapped these values right here, and we got a 2. Now we swap these values right here, and we also get a 2. So no. So 1. Sorry, these two values. Here. So the maximum possible swaps. Now we have a swap. We have like 2 swaps here, so it's 4. 1. So how many? Swap. So I guess you swap and then you go ahead and do another swap, then there's a problem, right? God damn. I think we need to stop our ThemeCP and just do 800s, I guess. Total sum is what? Total sum is 3 and 2, 5 and 1, 6. So we can output 3 values. In the case of 8, we have 8 and 9, 72. So 72. Wait a minute. So in this case, we have 2 into 3, 6. So sum is 3. In case of 3, we have CL of 3 by 2. Now, in the case of 8, we have 4 times 9. 4 9s are 36. 36. The answer is 17. So 15 into 4 is 60. So it's not about that. We have values from 1 to 6. 1, 2, 3, 6. So let's try a maximum possible. For a maximum possible sum of differences, sum of absolute differences, we have 6, 5, 4, 3, 2. So it becomes 5. This becomes 3. This becomes 1. This becomes 1. This becomes 5. So we have it all in pairs. 8, 10, 13 is possible. Then we can move these around. So if you move this and this around, we get this becomes 4 and this becomes it's the same thing. It's the same thing. So we have 5 into 10 to the power 2. Now we can go and I think do it even in n cubed if possible. So how do we generate subsets? how do we generate permutation? Then go about finding the differences. So I don't think this is an 800 rated problem. It's supposed to be really straightforward. I don't think this is the right way to solve this. We are doing 800s now.
Work today is broken. We're all working in too many disconnected apps, and it's killing team productivity.
Before starting and 3 minus 2, this would be take the index.
Today we're going to solve internet problems on the Amritsar. I'm not going to solve anything else. This is far too gone now.
TP mentor. This is me, Kumar K. Okay, you can check out. Okay, obviously we are going to discuss, and I'm going to announce. I'm very happy to announce that my student has cracked off-campus 40 LP SD2 offer from PayPal and SD1 offer from Amazon. He was my personal one-to-one mentoring and daily life training student for 2 years. Initially, he was not consistent. He was a total beginner in DSADF system design. 2 and subtract with 1, 2, you get 0. If you take permutation 2, 1 and subtract with 1, 2, you get difference 2. So I can write this whole ordeal, I can write this thing as, I can write this whole ordeal. Whatever I have made the observations till now, I can write it in a nice manner like this, that for n equal to 2, there are two differences possible. One is 2, another is 0. For n equal to 1, only one difference is possible because the permutation will only be 1. And difference of 1 with 1 will be 0. Now guys, let's say we have to find the answer of n equal to 3. Like to solve this problem in the exam, now you need to observe the test cases. See what's happening for n equal to 3. See what they're trying to explain you. Can you see the differences are always even numbers like 0, 2, 4. This gives you a hint. This gives you a hint. For n equal to 3, if you write like 1, 2, 3, 1, 2, 3, what is the difference? 0, 0, 0. So 0 difference is possible. This is the minimum difference possible for n equal to 3. What is the maximum difference possible? You write 1, 2, 3 in opposite order and subtract from 1 to 3. What is going to happen? 3 minus 1, 2. 2 minus 2, 0. 1 minus 3, 2. Absolute difference. 2 plus 0 plus 2, 4. So guys, minimum difference possible for the permutation is 0. 0 comes when you take 1, 2, 3 and subtract 1, 2, 3 with 1, 2, 3. And the maximum is when you write in reverse order. 4. Guys, it means all the even differences are possible like 0, 2 and 4. How am I able to do this observation? I can see for n equal to 1, 0 difference was possible. For n equal to 2, 0 and 2 is possible. For n equal to 3, 0, 2, 4 is possible. Can you see? Only even differences are coming. You only need to know the minimum difference and maximum difference, and all the even numbers in middle will surely be the answer. Done, 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 done. Enjoy this life. You are not enjoying. You're taking too much stress. Learn how to enjoy and de-stress and declutter. You need to enjoy, de-stress and declutter. You need to enjoy, de-stress and declutter. Okay? It's very, very important for you. Declutter. Relax your mind. Okay? Permutations will generate the middle differences, so that's not a problem. What is the maximum difference possible? That's how I thought when I looked at the problem in the contest. So for n equal to 4, well, 1, 2, 3, 4, 1, 2, 3, 4. This is minimum, right? 0, 0, 0, 0. This is not a big deal. If you want the maximum answer, this 1 should be paired with this 4, and this 4 here should be paired with this 1. This 1 should be paired with the 4, and this 4 should be paired with the 1. Like our main permutation, this will be our 4. This is our main permutation, and this is constant here, 1, 2, 3, 4. Why am I pairing the biggest number with smallest number? Because if I pair the biggest number with the smallest number, the difference will be big enough. I want maximum difference. That's why I'm doing this trick. If I pair the biggest number with smallest number, 4 minus 1 will give 3 and 1 minus 4 will give us 3. Now you have to decide the middle part. See, you have gotten the maximum difference for the first index and the last index. Now how do you get the maximum difference for the middle numbers? You will say, sir, in the middle there is 2 and 3. So what should I write about 2 and 3? If I write 2 and 3 only, the difference will be 0 plus 0, not good. But if you write the reverse, 3 and 2, then the difference will be 1 here, 1 plus 1. So you have to write 3 and 2 basically, okay? You just have to write 3 and 2 and the difference comes as 1, 1, 3, plus 1, 4, plus 1, 5, plus 3, 8. 8 guys, so all the differences we can come. 2, 4, 6, 8, like this. Can you feel it, baby? Can you feel it, bro? All we do is we know that the minimum difference 0 possible, maximum 8 possible. It means all the even numbers in middle will also be possible somehow. Because we can see that pattern. You don't need to explicitly prove it in the contest. But this much sense you need to put because it's a div to A problem. Cannot be that tough, right? Observe the pattern and just submit. Now, you might be thinking, sir, like I know to get the maximum difference, the first number we take the largest and the second number we take the smallest. But how will we know what number should we put here? This is nothing but the same answer as answer of 2. Whatever was the answer for n equal to 2, same type of numbers you can put here. Why? For n equal to 2, what was the max answer? Answer of 2 is 2. Answer of 2 tells you what is the maximum even difference. But how did this difference come to? You wrote 2, 1 here, you wrote 1, 2 here. This gives the maximum difference as 2, right? 1 minus 2, 1 plus 1. This answer for n equal to 2 can be replicated. For n equal to 2, you know that the answer was 2, 1, 1, 2, and this was. It is just that you want to keep the numbers 2, 3, 4, 5. So you will just add 1 to all of them. Add 1, 1, 1 here, 1 here, 1 here, 1 here. What is the difference? 6 minus 1, 5, 6 minus 1, 5. Now I don't know how should I put the permutation, first permutation and the second permutation of n equal to 4 here. I don't know how to do that, baby. I don't know that. But I know that I've already calculated answer of 4. I know what is the best answer. I know what is the best answer. If someone asks me to, keep the 4 numbers in a way such that the maximum difference is coming. The best answer is 8, right? Best answer is 8, right? These same numbers you can keep here. The same numbers you can keep here. It is just that you want to keep the numbers 2, 3, 4, 5. So you will just add 1 to all of them. Add 1, 1, 1 year, 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 1 year. Adding 1 to both the upper and below number does not affect the absolute difference. So you will write the same numbers here, but in the form of 2, 3, 4, 5. The answer of this was 8, so the answer of this whole part will come 10 plus 18. Guys, if minimum difference is 0, maximum is 18, then all the numbers in the middle. 18 by 2 different sums are possible. 0, 2, 4, 6, 8, 10, 12, 13, 12, 12, 14, 16, 18. Now guys, the final proof is, guys, sir, how can you guarantee that no matter what we do, the permutation, this, no matter what we do, this value, the sum of the absolute differences with the permutation, this value can differ only by an even number. So a sum will only get differentiated by an even number. So I will try to explain you the deep meaning of this, like nice deep meaning. The problem is very interesting. I love that too. So lovely students, let's say 4, 3, 2, 1. This is the permutation. Okay, what is the difference coming? 3, 1, 1, 3. If I swap, let's say I swap. If I swap these numbers, the new permutation will be 4, 2, 3, 1. What will be the difference? 3, 3, 0, 0. Can you see? Earlier the difference was 3 plus 3, 6, 7, 8. Now the difference is 6. The difference has been decreased by 2, baby. Did you get it or not? It means that your difference of 8 can become 6, 6 can become 4, 4 can become 2, 2 can become 0. Done, 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 done. This is it. You don't need to try all the permutations. Just by doing smart swaps, it is possible to generate all the even differences from max difference to smallest difference. Yeah, you do not even have to prove this in the exam. You can see the pattern. For n equal to 1, 0, then 0 to 4, n equal to 3, 0 to 4. It is common sense, man. Anyways, even if you did a different kind of swap, the difference in the new answer would still be even. Let's say you do a swap of you swap 2 and 1. 4, 3, 1, 2. Done, 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 done. Difference is 3. Difference is 1. 1 minus 3, 2. 2 minus 4, 2. This was what? 3 plus 1, 4. 3 plus 3, 6, 7, 8.
Okay. Do you... If you hear me, then please tell me. Maybe nobody wants to write anything, because I don't see any activity on the chat. Any new activity. Yeah. So I'll go with the solution. I can tell you, I was quite astounded with how hard was A. Like, I don't know, it was one of the hardest A that I saw. Yeah, A was really hard for me. Like, I saw it in 2 minutes, as you can see, but it was quite hard. So let's solve it. Okay. So, in this problem, we're given a function f, right? This function was taking a permutation p. For example, p could be equal to something like 1, 2, 4, 5, 3. And f from p was defined as sum over all indices, absolute value of p of this index or something, minus this index. So on this array, it would be 1 minus 1, plus 2 minus 2, plus 4 minus 3, plus 5 minus 3, 5 minus 4, plus 3 minus 5, absolute value of everything, right? So it would be 0, 0, 1, 1, and 2. And the sum of those values would be 4. Okay? So in this problem, we were asked a question, how many distinct values does this function take for the permutations of size n? Right? So, does anybody have any questions? Because, you know, it's my role to answer your questions. So if you have any, then please ask them. But I don't see any. So we will just solve the problem.
because everybody understands the statement. Like, if somebody doesn't understand the statement, then please tell what you don't understand, so I can explain it. But it's problem A, so why 4? Well, I have given you P, and I have written this sum here, and well, it's 4, as I see it. Okay, so let's go to the solution. So in this type of the problems, when you have this absolute value sum or something, or when you have the, I don't know, sum over all indices of something on permutation, then it might be a good idea to look at the smallest permutation, so 1, 2, 3, 4, 5, and the biggest permutation, right? 5, 4, 3, 2, 1. And if you look at this permutation, well, f from this permutation, like if this is permutation A, then f from A is equal to 0, right? On every index, the value is equal to index, so all the things here are equal to 0. And for this permutation, the sum is equal to something like, well, it's like, I don't know, it's something. I'm sorry, it's something, right? Like you can count it, but if I would be to, you don't need the formula for it, but if I would be to give the formula, it would be like n divided by 2 times n divided by 2 plus 1 times 2. Something like this. I'm not sure. It doesn't matter. So, now the trick is like this. Let's look at some permutation P, okay? And let's say that you swap two elements such that they form an inversion. So for example, such that they don't form an inversion. So for example, 3 and 4. They don't form an inversion, they're in the right order, right? So I say that the sum, and their value is, like I say that this sum will increase by, I don't know, some multiply of 2 or something. Like as you can see, I didn't prove it during contest, cause I didn't get the formula for permutation D. I just calculated it in my code, right? So when you look at my code,
Do you want to start building AI applications but don't know where to begin? Join the LangFlow AI competition and learn by doing.
When you look at my code in this problem, I calculate this formula, right? So I didn't get it using contest. And well, when you get the value for permutation B, you can just guess that you can get all the values between 0 and permutation B, right? You can just guess it, and then, well, if you you can get all even values between 0 and permutation B, and then if you guessed it, then well, you get accepted. But I tried to prove it here. Maybe I won't prove it. It depends on you. Do you want me to prove it, or if you don't, that's okay too. Like, I think you could prove it like this. You could start from the identity permutation, and then you could swap the inversions in it. By swapping it, you could create the inversions in it, and then when you create the inversion in it, it will change by, well, we can look at how much it will change. So let's say that I have some A, here I have some B. Well, it's test cases. Maybe if I draw it on a line. So this is a number line, here is A, here is B, and there's some index I that they are on, right? A is on index I, B is on index I plus 1. So let's say that I is, if I is here, okay, then, and I plus 1 is here, then like, because as you can know, absolute value is just the distance between 2 points on the number line, okay? I'm sorry that I'm making this so confusing, but I want to prove it. So, so first A is on position I and B is on position I plus 1. And how the function f changes when they are swapped? Well, it changes by this distance here, or does it even change? Yeah, it does not change. When I is here, it does not change. Let me just prove it. If I is, like you can see that here it does not change. I will tell you how to approach those kind of problems in a minute. If I is here, then it also doesn't change because it's symmetrical. And if I is between them, then I is here, I plus 1 is here. Notice that you always swap elements in the right order, right? And I plus 1 is here. Well, it's test cases. Maybe if I draw it on a line. So this is a number line. Here is A, here is B. And there's some index I that they are on, right? A is on index I, B is on index I plus 1. So let's say that I is, if I is here, okay, then, and I plus 1 is here, then like, because as you can know, absolute value is just the distance between 2 points on the number line, okay? I'm sorry that I'm making this so confusing, but I want to prove it. So, so first A is on position I and B is on position I plus 1. And how the function f changes when they are swapped? Well, it changes by this distance here, or does it even change? Yeah, it does not change. When I is here, it does not change. Let me just prove it. If I is, like you can see that here it does not change. I will tell you how to approach those kind of problems in a minute. If I is here, then it also doesn't change because it's symmetrical. And if I is between them, then I is here, I plus 1 is here. Then it's the interesting test case. Because right now A will go here and B will go here. So you can see that you add 2. Wow, that is beautiful. Okay, I feel very smart now. And I didn't even need ChatGPT. So basically what I have proven is that when okay, let me just go once again. I won't prove it, I just will tell you how to think about those kind of problems. As some of you may know, when you start from permutation that is identity, so this kind of permutation, 1, 2, 3, 4, 5, up to n, then you can get any permutation from it by swapping 2 elements, right? So for example, you could swap 3 and 4, and you want to swap elements that are in the right order. So for example, when you have permutation 1, 2, 3, 4, 5, you could get permutation 1, 2, 4, 5, 3 by first swapping 4 and 3, getting permutation 1, 2, 4, 3, 5, and then swapping 3 and 5. So notice that you always swap elements in the right order, right? So starting from the identity permutation, right now, it's very important that you hear me, because I am telling you how to solve those problems consistently, not by guessing. That is very important. So by starting from the identity permutation and swapping elements that are in the right order, so elements such that they're on the adjacent positions and the element on the left is smaller and the element on the bigger position is bigger, by swapping them, you can get from the identity permutation to any permutation. So if I could prove that the identity permutation gets a value 0 and the reverse permutation gets the value, I don't know, something, or some maximum value, then if I prove that every swap gives me plus 0 or plus 2 to my value, okay, then notice something like this. I start from the value 0, okay, I start from here, and by doing some operations, I only go up and end on maximum. So notice that between those two values, I go through every value, right? And that is beautiful. There's even a problem on code forces, it's called like zero sum code forces or something. It was like on a plane. Oh, it's this, I think. Yes. This problem is exactly for this trick. And look, this is diff to C. It's only this trick. So if you would know this trick, you could solve diff to C. This problem was solved by... it was not solved by me, because it was a long time ago. But this problem was solved by... Let's look. This problem was solved by, well, a little bit below 2,000 people. So it was probably around 1,600. So look, if you knew this trick that I'm telling you, you could solve this problem. Yes. And the trick is, look at the minimum value, look at the maximum value, and prove that you can get from the minimum value to the maximum value by doing some easy steps. And if those easy steps are plus 0 and plus 2, then you know that in between those two values, you will meet every other value. And that is beautiful. Because now I have proven to you, and I hope you understand this, that every value between 0 and the maximum, that is even, right? Because I'm going I'm doing only add 0 or add 2. I can't add 1. I can't change my parity. Exactly, every value appears there. And by proving this, we have shown together that, well, guess what? All the values between disappear. And proving that odd values can't appear is very easy. I can show it to you, but maybe I will read, how to say this? Maybe I will left it for you as an exercise. You can prove it the same way. That's what I will tell, and I will go to problem B. So who likes my solution to problem A, and who understood?
This is a very weird problem. I'm just going to do 800 problems now.
I think most people solved it by guessing. And well, you could just look at the examples and get the formula. But look, if you do it like this, you won't learn anything. And your goal is not to solve problem A. You are not here to solve problem A. Your goal during contest was to solve problem A. Right now, your goal is to get better, to train your skills by listening to me, right? So I'm telling you this beautiful method of solving the problems, right? You want to look at the continuous function as somebody said, and by knowing this method, by practicing it, you can get really better at solving problems. The problem that is the same as this one, I have sent link on the chat, as you can see. It's the
let's move on to the first question. Okay. A is permutation warm up. For permutation, P of length n, we define the function f of p is equal to the summation of I equal to 1 to n of p of I minus I. Okay. You're given a number n, you need to compute how many distinct values the function f of p can take when considering all the possible permutation of numbers from 1 to n. Okay. So what do we mean by that? So let's try to understand. I did only two. Today I did only two. The third one I was stuck with the very silly point. Okay. Even you did too, that's great. So the third one I was stuck with a very silly point. I'll explain you what I was stuck with. So but yeah, I couldn't solve the third one also. Like it was a kind of edge case and I knew what the edge case was, but I wasn't able to figure out how to solve that edge case. Okay. So for the first one, yeah, you're given this. Okay. So what we mean by that is very simple. Let's say if you're having permutation 1, 5, 6, like let's have a little smaller permutation 1, 4, 2, 3. Okay. Now that you know that this is the permutation, so for this one, it is in which position? Sorry. I think I will be needing a copy to rest my mouse on. Okay. So basically, okay, let's leave it now for now. Okay. So what are these positions at? So this is at 1, which means 1 and 1 cancel. This is at second position, so it will give me yield a value of 2, right? This is at the third position, so 2 minus 3, that is 1. And this is at fourth position, that is 3 minus 4, that is 1. So what is the value of it? What is the score of it? So it is nothing but 2 plus 1 plus 1, that is 4, right? Now if you note, so you have to find out how many different values can this reach. Okay, so if you find out one thing very interesting, that is if there are, let's say 3 numbers, okay? Good evening, man, good evening. So if there are 3 numbers, in this case there are 4 numbers, so first of all let's say if there are 3 numbers, among which 1, 2, 3, right? There are 3 numbers, 1, 2, 3. Among which 2 of them will be odd and 1 will be even, right? Now, no matter however you put the odds and evens, one of the odd will be in the odd position only, and the other odd can be in the odd position or in the even position. And depending on that, the other even will be in that position, in the different position respectively. I think like you won't be understanding what I mean. So let's say it is 1, 2, 3. Okay, so it is odd, even, Okay, odd. Yeah, I think today's questions were quite intuitive. Like, it was quite good, I think. It's good that lead code is, not lead code, code forces is doing this great job. Like, from the first question, they're trying to put us into trouble. Okay, that's a good thing. So let's say this is odd, even odd. So no matter however you put this odd can go either in this position or in this position or remain in this position, right? Now, if it is in this position only, so that is odd and odd, right? If it is going from here to here, so then also it is getting extended with an odd position only. So the odd number is getting into odd position. Only if it is coming over here, then only that is the odd number is coming into even position, right? And once this odd number comes to this even position, now the even position has to by default go either into this position or this position, and the other odd number will be remaining in the odd position. Okay. So what do I try to convey using this? What I try to convey is that even minus odd, right? Like whatever the value of it is. So even minus odd minus even minus odd minus even. Both of them are odd. Even minus even is even. Odd minus odd is odd. Odd minus odd is even, right? Now, if the odd is going to the odd position, it is going to yield a value of even, right? If the even is going to an odd position, it is going to yield a value of odd. And since that went to the even position, now the even has to go to some other odd position, which is also going to give a value which is odd. Now again, odd plus odd is even. So if you look at this permutation, no matter however you make the permutation, it can be proven that the score or whatever it is called, what is it called? The function, the value of the function, okay, f of p, it is always even, right? Now that I know that it is always even. So I know one thing, that if I can find out what is the maximum possible value that the permutation can make, I can have a kind of knowledge about how to find out all the distinct numbers, right? What do I mean by that? Let's say if it is 1, 4, 2, 3. What was the score of this? What was the value of function of that? It was 4, right? But how to maximize this? In order to maximize this, you have to completely reverse the whole thing. So that which is at the minimum will be facing the maximum, and which is at the maximum will be facing the minimum. That is, we will make it like 4, 3, 2, 1, right? Now that we have got 4, 3, 2, 1, which means it will be 1, 2, the positions, okay? 1, 2, 3, 4. This is 3, this is 1. This is 1, this is 3. So what is the sum of it? 6, 7, 8, right? So 8 is the sum. Now if I tell you, can you make the sum 6? Yes, you can. See, if I tell you, can you make the sum 4 or not? Yeah, you can do it easily. Not a big issue, okay? How can you make it 6? So first of all, let's try to understand what is the permutation combination that we can have. Let's have a brute force approach for it, okay? So what if I reverse this 1 and 2? What will happen? This will become 2 and this will become 2. There's nothing much change, right? So remove, like, giving it this 1 and 2 a try is not worth it. What if I change this 1 and 3? Okay. Do you think it will be worth it? 1 and 3? Obviously it is worth it, because 1, this is 1, but this becomes 1. Now it is a 6. Clear? So we could make it 6. For 4, we have already checked it out. And what if I want to make it 2? Okay, very simple. 1, 3, 2, 4. Because if I'm switching these two positions, so this is the position that is going to matter, and it is going to matter by 1. So 1 plus 1 is 2. So for 2, 4, 6, 8, we got it, and we know that if we are putting it in normal increasing order, it will be 0. So what are the distinct numbers? It is 0, 2, 4, 6, 8. So once if I can get the maximum value that I can get from it, I know that all the even numbers that are lesser than that and greater than equal to 0 are valid. Okay, that is basically, since in this case it was 8. So how many numbers greater than 0 can be even and is lesser than equal to 8? Is less than equal to 8? It is 8 by 2, right? And including 0, it will be 8 by 2 plus 1. So what is it?